Anytime you guys find yourself in a situation where you're taking labs like this and you're 99.9% sure that you were correct or there was some type of bug, take a screenshot of it and shoot it over to me or to the program director. Excuse me 1 second. Sorry about that. Allergies are killing me. Okay. Oh. $14, not $19. That's in Linux and terminal. It looks like a standard ping. Yeah, shoot that over, shoot what the result was. We'll get that going. 1 second. Okay. So, topic 3C. It's quite a lot to get through here, so this topic will occupy a fair amount of presentation time and practical lab work. We're going to go over deploying common Ethernet switching features, Ethernet switch types, so on and so forth. Ethernet switch types differ from vendors. They come in a variety of ranges to support a variety size of networks. While a basic model might feature 12 to 48 ports and little scope for expansion, advanced switches support interconnections via high-speed backplanes and expandable capacity through plug-in modules plus power supply redundancy, management consoles, and transceivers for fiber optic connectivity. See over here, number of ports, stackables. When you have stackables, you're going to have one primary switch feeding into the rest of the switches. And those will always be mapped and maintained. Each one of these switches should be able to have a little insert to deploy and say, you know, port 108, port 109. You should be able to map that throughout the building. Of course, that also comes in turn if you end up needing to use patch panels. We discussed that in our last class. Remember that you can use patch panels as well, minimizing the amount of switches that you need. Oh, that's in the labs. Are you getting a little ahead of yourself there, Tanya? Or was that part of the last lab?
So I thought we were working on tonight's labs, and that would be the configure interface settings. That's what I was working on, so I kind of got stuck here on this lab.
Configure interface settings. One moment. Okay, so that's actually this next coming lab after this here, I believe.
Oh, okay. I guess I'm getting ahead of myself. Sorry.
Oh, no worries. That's good for you guys. That's good.
Okay, well, let me just go ahead and save it for now.
Yeah, no worries. Eagerness is good. And always remember, you can redo the labs. So let's see here. We're to go over switches. And now you guys have heard me discuss, first off, the brand of switches that we've discussed: Netgear, Cisco, HP, Hawaii, Juniper, Arista, Aruba. There's so many different vendors for switches. What you need to get used to is your comfortability of deploying them, their interfaces, and of course, when you start building out script databases or backups for template settings, it's going to be standard for whatever switch you're using for that company. Ethernet switches can be distinguished by the following categories. You guys have heard me say this. We have over here a managed ProSafe switch, which allows me to control certain parts of the device. Oh man, that's horrible. this guy here. And of course, you can see the switches ports up in front. Usually with a switch like this, you would have one feed in through the WLAN, and then the rest of the ports would spit out this way into your workstations. Unmanaged versus managed. On a SOHO network, you guys remember what a SOHO network is, right? Small office, home business, home network. Switches are more likely to come unmanaged, standalone units that can be added to the network and run without any configuration. So this is generally a plug-and-play switch. You can show up, say, okay, well, this modem only has 4 ports. The client needs, 6 additional ports. We're going to get them a 24-port switch. You could take essentially 1 port from the modem, connect it to the switch, doesn't matter what port, and then start connecting out workstations or doing runs from that switch itself. You don't have to worry about any delegation, any VLANs, any subnets. It just automatically spits out IP. The switch functionality might also be built into an internal router modem. On a corporate network, switches are more likely to be managed. This means that the switch settings can be configured. If a managed switch is left unconfigured, it functions the same as unmanaged switches. That is a standard, but remember that with certain switches like the Netgear ProSafe, you still have to go in there and enable certain settings and put in your IP scheme, unless you just switch it to DHCP. Okay, switches. We'll get into that here in a second. We just discussed that, and that's actually going to be, they don't add that to your slide until later. But our introduction here is going to discuss backplanes here in a minute. We're going to go through the stackable and unstackable, well, stackable and normal, modular, fixed. So the type of switches that you have are stackable switches. These are switches that can be connected together and operate as a group. A switch stack can be managed as a single unit. So generally you have several switches. They all have one general user interface, a GUI, or a cloud login that you can manage that. Modular versus fixed. A fixed switch comes with a set number of ports that cannot be changed or upgraded. A modular switch has slots for plug-in cards, meaning they can be configured with different numbers of and types of ports. Remember, some of those modular ports allow you to add SFP and other connections for your switch. Desktop versus rack mounted. And this is generally just going to be as far as if you have a network closet or a telecommunications closet, a DVR that's mounted into a rack. Simple unmanaged switches with 5 or 8 ports might be supplied as a small freestanding unit that can be placed on a desk or a desktop. Larger switches are to be fitted into a standard size rack. How many of you have actually seen a network rack before? You might see it at the Albuquerque campus in the hallway in CNST. Absolutely. So usually with those racks, the switches can slide right in. They have some brackets that you screw into the side, and of course provided a bracket that you can screw into the rack itself. That allows you to put in as many switches as you have. And there's full racks that are as tall as, I think, 7 to 8 feet tall. And of course there's box racks as well. You get rack mounts that you mount into a wall that come with a lock cabinet. And those are the standard ones that you usually use for compliance purposes. Okay, switch interface configuration, command mode. Configuration of a managed switch can be performed at a command line interface, CLI. Once you established a connection to the switch's management interface, you can configure the settings for each of the switch port interfaces. These settings control the network link configured for each client device attaching to the switch. Most switch operations work in multiple command modes or hierarchies. For example, Cisco's iOS has 3 principal modes: user executive mode, EXE. This is a read-only mode where the commands can be used to report the configuration and show status or run basic troubleshooting. It doesn't write anything to the actual switch or any of configuration files. Privilege exec mode, enable mode. This allows the user to reboot or shut down the appliance and back up and restore system configuration. As I said, there are template files or configuration files that you can download. or you can build yourself. That way, when you're deploying certain switches, you have a configuration file to upload, has your default settings, has your default rules, and then you can tailor them to your client's needs. Global configuration mode. This allows the user to write configuration updates. This is actually the full administrative mode. So if you need to do any changes to your configuration file, DNS information, DHCP stuff, that's all available through your global configuration mode. Let's see. Most CLIs support tab and or use of question mark to list different ways to complete partial instruction. Remember that you'll also have the option to /help as well. In user mode, a variety of show commands can be displayed to the current configuration. These are usually many show commands, but two particular importance are as follows. Show config displays shows the switch's configuration. The startup configuration, show, and of course, remember your parentheses, open parentheses, show startup -config, close parentheses, could be different from running configuration, show running config, close parentheses. If there are some undocumented changes to the switch, using these commands and comparing the output may reveal the source of the problem. So if you guys end up having a colleague or someone that works with you that states, hey, there's something going on client site, we are not sure what's happening. I did some updates, some firmware updates on the switch. And you're like, well, yeah, is that really all you did? In most situations, you got to take everything at face value. Yeah, I ran some updates, but sometimes they forget that they disabled some ports, or did something obscure. And these commands will help you actually run a comparison to ensure that you can see the logs, see what was changed, and see what's different. Show interface lists the state of all interfaces or the specified interface. Interfaces are identified by type, slot, and port number. And we basically saw that earlier when we showed you guys how to check that report log, and you did that review. So generally, Gigabit Ethernet 02 or GO2 is port number 2 on the first 10, 100,000 slot or only slot. An interface that has a line status, up if a host is connected via good cable, and a protocol status, up if an Ethernet link is established. Down indicates fault, while administratively down indicates the port has been purposefully disabled. Show interface will also report configuration details and traffic statistics if the link is up /up. And of course, that's what they generally tell you about managed switches. Remember what I said, it's a full software set integrated into the switch that you can say, hey, port 1, enable, all other ports disable. That way you can ensure, like I said with the previous class, no one just shows up and plugs into the switch and can get access to it or access to the network. And of course, there's a demonstration there of the command, what you can run to show what's up, what's running, what's being received, output rate every 5 minutes, the whole 9 yards. Now, just a side note, switches normally support a range of Ethernet standards so that older and newer network adapters can connect to the same network. Remember, we said fast Ethernet and gigabit Ethernet are backwards compatible with each other. So you won't ever have to worry about that. In most cases on the switch, it's set to auto negotiate speed, whether it's 10, 100, or a gigabit, and at full or half duplex operation. A static configuration can be applied manually if necessary. And remember, when you're applying that static configuration, you have to apply it not just on the switch level, but also on the network adapter level on the host. Auto MDI, MDIX. Hopefully you guys recognize that terminology from the last review and the last discussion we had. Okay, make sure that we're still recording. Awesome. Under 100 base T, an end system uses media dependent interface, MDI, to transmit on pins 1 and 2 and receive on pins 3 and 6. This is also referred to as an uplink port. As an intermediate system, a switch port uses MDIX and receive data on pins 1 and 2 and transmits on pins 3 and 6. The cable between the host interface port and the switch interface port should be straight through, either T568A on both ends or T568B on both ends. And remember, that's a standard that you should hold to your entire network. We deployed a network for Southwest Labs, and they're actually right next to the Teamster building. We ended up deploying, I think it was 187 runs, and we had to come to a standard and ensure that 3 network technicians, myself, Stephen Mooney, and David Jackson, were able to come to an agreement and say, hey, we're going to run all these lines A or all these lines B. And of course, we had to go through and test every single one, terminate them, and make sure that they were functioning. So when a switch needs to be connected to another switch, communications would fail if both interfaces use MDIX. Historically, in the days of hubs, which you guys won't see anymore with the 10-100 switches, dedicated uplink ports and or crossover cables were used to make these connections. A crossover cable has a T56A termination at one end and a T56B termination at the other end. And that's why they call it a crossover cable, because it allows you to switch. Nowadays, most interfaces are configured to use auto MDI, MDIX by default. This means that the switch senses the configuration of the connected device and cable wiring to ensure that MDI uplink MDIX port gets configured. This will also ensure a link if a crossover cable is used to connect an end-to-end system by mistake. The principle applies to gigabit Ethernet and faster. MAC address table and port security. A switch learns MAC addresses by reading the source address when a frame is received on a port. The address mapping for that port is normally cached in a MAC address table. Remember, we've discussed MAC address tables before. And as you can see there, it's a little demonstration of a list of the MAC addresses that have been on the network, whether they're dynamic or static, and the ports that they're occupying. Consequently, well, sorry, my apologies. The address table is implemented as content addressable memory, CAM, a special type of memory optimized for searching rather than random access memory, which you guys should remember from your A+ certification, which is just standard general RAM. Consequently, the MAC address table is often referred to as a CAM table, entries remaining in the MAC address table for a period before being flushed. This ensures problems are not encountered when network cards' MAC addresses are changed. If a MAC address cannot be found in the MAC address table, then the switch acts like a hub and transmits the frame out of all the ports except for the source port. This is referred to as flooding. Flooding is another term that you will hear when you get into penetration too, as far as network penetration. You can query the MAC address table of a switch to find the MAC address or addresses associated with particular port by using the command show MAC space address hyphen table. Of course, that's how you get that nice little list there that we're seeing. A port security configuration validates the MAC address at the end systems that connect to the switch port. In most scenarios, you would not expect a MAC address of servers and workstations to change often, except for predictable upgrade cycles. Unknown or frequently changing host MAC address might indicate an intrusion attempt. A port security configuration has 2 elements. Specify a static MAC address or allow the port to learn and accept a certain number of sticky addresses. Specify an enforcement action when a policy violation is detected. Alert only, shut down the port, or shut down the network. Get on to our next slide. Port aggregation. Port aggregation means combining 2 or more separate cabled links into a single logical channel. From the host end, this can be called NIC teaming. The term bonding is widely substituted for aggregation. For example, a single network adapter and cable segment might support 1 gigabit. Bonding this with another adapter and cable segment gives a link of 2 gigabit. Port aggregation is often implemented by a link aggregation control protocol, LACP, and this can be used to auto-negotiate the bonded link between the switch ports and the end system, detect configuration errors, and recover from failure of one of the physical links. And of course, a lot of the times you'll set this up on servers as far as it comes to a business. you'll have a network card with up to 6 Ethernet ports in the back. And then you'll have to set up your port aggregation depending on, how many of them you have connected in. Port mirroring. We were discussing this when we were talking about doing the packet sniffing. We have to have a port mirrored to another device that's doing the sniffing. Unlike a hub, a switch forwards unicast traffic only to a specific port and intended destination interface. This prevents sniffing of unicast traffic by hosts attached to the same switch. There are some circumstances in which capturing and analyzing network traffic is legitimate activity. However, and port mirroring provides the facility to do this. Port mirroring copies all the packets sent to one or more source ports to a mirror destination port. On a Cisco switch, this is referred to as a switched port analyzer. And we see that term again, span, right? And that's when we connect a span to a device, mirror the port, and start doing a packet sniffer analysis to determine what's coming in and out for everything. But as you remember in our last review, span isn't necessarily the best way to analyze intrusions. The mirror port would be used by management or mirror monitoring software such as a packet sniffer, Wireshark, Snort, Kali, a network analyzer, or an intrusion detection sensor. Either egress or ingress traffic or both can be captured. Optionally, in order to avoid overloading the monitoring system, packets may be filtered based on criteria such as ID protocol, TCP, UDP port number. So if you believe that someone's attacking that port number that I gave you the other day, 8080, you can specify the packet sniffer to only monitor that port, whether it's a UDP or a TCP port. Same thing for your internet. Same thing for any HTTP traffic, also any traffic coming in from your IMAP, and that's your port 25, port 26. Jumbo frames and control. And of course, we see here the port mirroring. Set it to unicast. And there it's just showing what you're getting out of that mirror session. The range of the ports. And you're typing in here as well, ingress and egress. That way you get both flows. Jumbo frames and flow control. Some types of hosts, such as those implementing storage area networks, called SANs, have special requirements. Traffic processed by these hosts can be optimized by configuring port settings for jumbo frames and flow control. Jumbo frames, ordinarily an Ethernet frame, can carry data payload or maximum transition unit of up to, remember this guys, 1500 bytes. And that's maximum. And that's a frame from 46 to 1500 bytes. When you are transferring data around a storage network with 10 gigabits switching fabric, a 1500 byte limit means using a lot of frames. A jumbo frame is one that supports a payload of up to around 9,000 bytes. And that's why they call it a jumbo frame. This reduces the number of frames to be transmitted, which can reduce the amount of processing that switches and routers need to do. It also reduces the bandwidth requirement somewhat, but not all the way, as fewer frame headers are being transmitted. The benefits of jumbo frames are somewhat disputed, however. When implementing jumbo frames, it is critical that all host appliance, switches, and routers along the communication paths be able and configured to support them. So if you set one device for jumbo frames or anything else, all devices have to be set to that as well on the network. Okay, so moving forward, it is also vital to ensure that each device supports the same MTU. Also, it can be complex to calculate the MTU if any additional headers are used for IPsec, for instance. The MTU value in show interface output will indicate whether jumbo frames are accepted on a particular port. And remember, you can specify what port by telling it ETH0, then the port number, so on and so forth. And you guys have already gone over how to delegate that. Flow control. IEEA 802.3x standard flow control allows server to instruct. I'm not getting into power over Ethernet, but I'll prep us for it. The switch and to pause traffic, temporarily avoid overwhelming its buffer and causing to drop frames. A switch port can be configured to enable or disable use of pause frames. The 802.3x global pause mechanism does not distinguish between traffic types, however, which can pose problems with voice, video, traffic, infrastructure, critical traffic, such as protocol updates. So when you have voice over IP over this protocol, you're going to have issues. Class of service, which used to be called quality of service, and in some older routers it still is, mechanisms ensure reliable performance for these time-sensitive applications by marking and policing traffic. The updated priority flow control PFC mechanism, IEEE 802.1 QBB, allows pause frames to apply to certain traffic classes only. Now, who remembers back in their gaming days having to get into their router and enable quality of service? Absolutely. If you had an Xbox back in the day, the original 360s, you would have to get into your router back in the day, and you would have to go into your QoS settings and make sure that your Xbox or whatever you were gaming with had a priority over everything in the network. Nowadays, you don't have to worry about that. Auto QoS or COS is part of a system in most routers, but in some situations, you still want manual control over that, because who knows, even though it's automatically delegating your Plex server to have quality of service, maybe you don't want it to do that just because it's the most performing item throughout the day or throughout the week on your network. You don't want your modem to give it priority. You want your modem to give you, your computer, your gaming system, your PC, whatever it is, priority over that Plex server. Now we're going to discuss power over Ethernet, PoE, and that's a means of supplying electrical power from a switch through an ordinary cat cable connected to a powered device, such as a voice over IP phone, a wired camera, a wireless access point, and that ensures that you are minimizing your cabling and not having to require a electrician to come up and install a power box next to your IP camera. That's why a lot of IP cameras are now standard PoE. So, let's see. PoE is defined in two IEEE standards, now both rolled into 802.3 2018. 802.3 AF. Power devices can draw up to 13 watts over the link. Power is supplied as a 300 megahertz and 48 watt and limited to a 15.4 watt, but the wattage drop over the maximum 100 feet of cable results in usable power of 13 watts. So remember that if you have a device that's required to run the full 14.4 or 15.4, your maximum distance for that from your PoE switch, and that's a dedicated switch that has specific ports for powering devices. Some switches will only give you 4 PoE ports, and the rest of the ports are normal ports. And some switches that are a lot more expensive are actually just all PoE. So keep that in mind. If you have a, IP camera that you need to run 200 feet, and that camera is rated on the box for 13 watts or 12, most of the time, most things are 12, you should be able to run it over 100 feet. What's the maximum for Ethernet cable one more time, guys, for Cat 5, Cat 5e, and Cat 6? Remember, Mr. Anderson wanted us to use meters. In feet, it was a very specific number. In meters, it was just, we'll call it a buck. 100 meters. That is correct. That's 328 feet. But in the tests, it's going to ask you in meters. So remember, 100 meters. And we have that reference up in the chat above as well, as far as cable lengths when they start experiencing signal loss. Standard 802.3 AT, which is known as PoE+, powered devices can draw up to 25 watts with a maximum current of 600. Now, this is usually when you get into a situation where you have to make sure when you look at your PoE devices, do you need standard PoE, PoE Plus, or Ultra PoE? And the difference is the wattage types. In certain situations, you can just buy a PoE adapter, which is literally just a power brick that connects to the wall and converts to Ethernet and powers the Ethernet cable over the brick. Okay, so 802.3BT, Ultra PoE. That's up to 51 watts, type 3, or 73 watts for type 4 for usable power. And for that, you'll usually see PTZ cameras and a lot more heavier devices, the ones that kind of require power to move around or keep something on or draw additional power. PoE switches are referred to end-span or endpoint. Power sourcing equipment, PSE. If an existing switch does not support PoE, a device called a power injector or mid-span can be used. And that's the block that I was telling you guys. The power injector is the block that you connect to the wall, then of course converts to PoE. When a device is connected to a port on a PoE switch, the switch goes through a detection phase to determine whether the device is PoE enabled. If not, it does not supply power over the port. Therefore, it does not damage any non-PoE devices. So if you have any clients say, well, I have a switch, but all the ports that I have say that they provide power, and I have, a computer that doesn't need PoE, you can tell them, hey, it's all right. It's not going to provide power. It's going to go through a cycle and check, hey, does this device need power? Does it require me to provide it 15, 13 watts? What do we need to provide it? And if the system feeds back and says, hey, I'm a motherboard, I don't need PoE, buddy, it will send power to your motherboard and kill it. So powering these devices through a switch is more efficient than using a wall socket AC adapter for every appliance. Because imagine if every campus, every hospital had a power outlet right next to every single camera. That would be absurd. Electricians would be rolling in the dough, and we would be in a completely different career field right now. It also allows network management software to control devices and apply schemes, such as making unused devices go into sleep states, power capping, schedules, so many things you can do with PoE. So now that we're here, guys, we're going to review some of this. And you guys let me know how you feel, okay, after this is all done. You need to verify whether a switch port is misconfigured by checking the number of collisions being reported. What general command could you use at the CLI to report this information? What command? Yes. Good job, guys. Show interface. Next question. True or false? A managed switch can have auto MDI, MDIX enabled by default. Yep. And that's usually the standard. It's going to be coming in by default. Normally, it used to be back in the day that you had to enable it. Now it's just something they leave enabled standard. A technician configures a switch port with a list of approved MAC addresses. What type of feature has been enabled? So the MAC address table would be the list where you get all those addresses of each device, how they're assigned for their IP. But that would be port security. Anything that denies or allows traffic into the switch would be port security, and especially when you're getting into MAC addresses. Remember the other day I was showing you how people can get as paranoid as to set up static IPs for their network and only allow certain systems with certain static IPs that are assigned in there. This is another form of also providing security, providing MAC addressing, saying, hey, if your system doesn't match this MAC address, you're not going to be allowed on the network. Doesn't matter if you have a static IP. Guess what? You changed a network card in your computer. You changed a processor in your computer. Your MAC address changed. In some instances, like it stated, the switch will determine if it was a small change like that and allow the system in. But if it can't, you'll have to do a MAC address adjustment in your port security list. So number 4, a server has a 4-port gigabit Ethernet card. Remember, I told you they can go up to 4 to 6. If a switch supports port aggregation, what bandwidth link can be achieved? Remember, this is like your Stripe RAID for your hard drives. Exactly, 4x1 or 4. You can run all 4 ports at 1 gigabit, or you can have them all flow control into 4 gigabits. That actually was this last section. Let me pull that up for you. Aggregation. For aggregation, right here, it's going to be topic 3C. In my book, it's going to be page 69. Giggity. And I'll provide that here. And you have to just remember the general concept of the idea of stripe RAID. You're using several hard drives to essentially stripe them together and aggregate into one giant space for a hard drive. Same thing for these aggregation for the ports for gigabit. If you have 4 ports that equal a gigabit, you can turn them all into 4 1 gigabit ports or have them aggregate to 1 4 gigabit port. And of course, you're experiencing nowadays that we have 100 gigabit cards and everything else, so you can do the same thing for those as well. Number 5, what port configuration feature allows a server to smooth incoming traffic rates? Host Tavares. It's actually the IEEE 802.3x flow control. Your port mirroring would be something that you use when you need to sniff packets on a router, switch, or modem and determine what data is going through. And if you need the section on that, just let me know and I'll help you find that too. Number 6, can you safely connect a server to a PoE port that's enabled, or should you disable PoE first? Remember what I was saying about that phase. No need to disable. So the great thing about switches and PoE ports is, remember, they enter that phase where they initially go through and check the route and say, hey, does this device require PoE? And when it comes back with the information saying, hey, this requires 13 watts, this requires 15.4 watts, this requires 71 watts, the PoE switch will provide what is needed. But if the device that's connected on the other end says, hey, I'm just a motherboard, all I need is info, or hey, all I am is just, a laptop. I just need info. I don't need power. And it won't require power. It won't send out the power, so you won't have to worry about shorting out your devices. And hopefully, I mean, one day I'm hoping we get to the standard where it's just we have PoE Ethernet for all devices, and motherboards can just be powered by PoE, and we don't have to worry about having these 1600-watt power supplies. That's just insane. Awesome, guys. We're going to go over the summary here. You should be able to identify network devices now that are operating in layers 1 and 2. You should be able to determine their appropriate placement on the network, and you should be able to deploy and configure Ethernet switches with appropriate port configurations. Remember, when it comes down to that, that's your port security, that's your enable, disable, so on and so forth. All those things for as far as setting up report logs and seeing your port packet sniffers and setting them for snap, tap, advanced tap, so on and so forth. You'll be able to configure appropriate port settings for high bandwidth loss, such as link aggregation, jumbo frames, and flow control. Remember, if you set up jumbo frames on one device or on one modem or router or switch, you have to set it up on all the other devices as well. Make sure that they're all enabled. And you do have a command that you can use in your switch, whether it's a Cisco switch, to determine if jumbo frames are enabled on the device itself. Usually they're not, though. That's one of the things that aren't turned on automatically. You'll be able to identify any hosts that require non-standard configurations, such as disabling auto negotiation of speed, duplex settings of half or full, and you should be able to disable auto MDI or MDI-X. You should be able to identify crossover cables as far as their connections from one tip to another. You should be able to create a management plan for a legacy hub and bridge appliances to ensure that they do not impact overall performance. Remember the issues of hubs over bridges to why we use switches now and they're the standard. You should be able to identify any physical layer repeater or media converter functions that cannot be met by installing a switch. Remember, usually when you use a repeater, it's because of limitation of the network or distance. So you need a repeater at about 328 feet, but the testing requires you to go in meters. So that's going to be 100 meters even. You'll be able to make a plan for capturing network traffic. Exactly, 100 meters. You'll be able to make a plan for capturing network traffic at strategic points in the network, either through port mirroring or via network tap or snap. Optionally, you should be able to use known or locally administered MAC addresses and port security to mitigate the risk of unknown devices connecting to the network. And generally, like I was saying, this should be the last part of lesson 3. We should be able to go through and be able to set up that network that we were discussing in the lab. If there are any questions you have, let me know. I'm going to look through our syllabus and our course modules. And it looks like we have the rest of the time for the lab. And Bob was right. I finished these classes kind of early. Do you guys feel like I go through this material too fast? Thank you, Lilashan. I appreciate that, Devaris. Caleb, let me know. I'll slow things down at any time. I'll go back anytime I need to. Always remember that I do record these up in the file tab. In our chat, you can see the files that are recorded as well. And I'll always be willing to provide you any information that you need. No, Caleb, remember, no one's ever slow, man. It's always good to retain information. A lot of the times when I got into this industry, man, I had to just sit there and hammer myself, and eventually I'd start dreaming in hexadecimal, and I start dreaming in binary. And once I started studying PHP and JavaScript, next thing you know, my girlfriend's waking me up and saying, "You're talking in your sleep, and you're saying dot this and close class this and open class this." So don't worry, don't beat yourself too much about it. We're here till 10. If you guys need me to review anything else, let me know. That's funny, Devaris. But let's get through those labs. I'll give you guys about 15 minutes, and then I'll come back and check in on you. That way you can go back to that lab, take a look, and let me know what you think. And here in 15 minutes, we'll take another break for 10 minutes. That way you guys can just take a breather, go out, play with your puppers. I got 5 of them right here just chilling, looking at me. So let's take those 15 minutes and do those labs, and I'll be back to check on you. I'll see you all in about 15.
Now we're going to take some time to learn a little bit about how to install and configure a switch. Now, the first step to installing a switch is to, well, get a switch. So we need to go and see about purchasing a switch and getting it. Now, purchasing a switch is a little harder than you might think because we've got to make sure we select the right switch for our job. And there are so many different choices that are out there. Let's take a look at Cisco's product line to get a good example. There's many different manufacturers that are out there. They all create various switches. On Cisco's side, they generally focus on enterprise and business switches. And so you'll see they have a number of different options. LAN switches, which are generally multi-purpose. You have core and distribution switches, which are designed for large enterprises and data centers, even ISPs. So some of these switches are very, very large. Others are designed for small business, like branch offices where you have a small amount of people. You need to understand where your switch is going to be used to select the right one because the cost on these vary significantly. A switch, like for example, a Linksys switch, could be as little as $50 at your local computer store, right? Here's a little 5-port switch for $37. Or a bigger switch, like a 48-port switch. Let's see if we can find one. Well, it's 24 ports, a decent density there. So a 24-port switch, this one is about $300, right? So each of those vary in price based on how many ports you're getting and how you intend to use it. When you start talking about some of these larger switches, they could be $100,000. That's not something you want to put in your home. It is something an ISP would need. So we have to select the right switch for the job. After we've picked the right switch, we have to figure out where we're going to put it. And when I say where we're going to put it, I don't mean like a core distribution layer. I mean where we're physically going to put it. There's a lot of different places that a switch can go. For example, if it's a standard desktop switch, you might take a desktop switch and mount it underneath your desk. Right? This is actually a picture from underneath my desk in my office. I've got a Netgear switch that I have a cable running in that's my main network cable, and then I split it to run to my computer and to my VoIP phone. So those two connections are kind of coming out here on the right side. Now, I know it looks upside down, and that's because I mounted it upside down. I wanted the cables to point upwards. On a switch, they generally don't care if they're pointed up or down, if they're upside down, upside right. But one thing we need to be considerate of is the way air flows through the switch. On a desktop switch, perfectly fine to mount it just like this, not a big deal. But on an enterprise switch, it can be a lot more challenging because you typically have a lot more density. And when I say density, let me show you another example here. This is an example of 5 48-port switches stacked on top of each other. They're all right down here towards the bottom of this photo. So you can kind of see them. They're a little hard to see because of all the cables that are coming out of them. Now, when we plug in cables at this density level, it's important that we cable manage them so that we can still visually see the switch. There's a lot of indicator lights on the front that if the cable blocks it, we can't see them. Another thing to consider is unlike servers, where air is normally taken in the front and blown out the back, so you have hot air coming out the backside of a server, switches and network gear is typically side to side. In other words, air is being sucked in from the left side and blown out to the right side. So if we mount these switches upside down or mount them next to another rack really close, we could be obstructing the airflow and not getting cool air into the switches, leading to an overheat situation. That's something you want to avoid. So how we place these is really important. Let me show you an example of a pretty typical wiring closet right here. It's a single rack that has a little bit of a ladder mounted on top of it. And that ladder is so we can have all the cables that run from all the various workstations on this particular floor are running to this one place. They come out of the ceiling and into the ladder. Now, I know it looks like the cables run way off to the right, but it's actually just a loop, and it comes right back again where they divide in half to run down the left and right side of the rack, where they then run in to these patch panels. Patch panels are an important part of getting a switch operation like this set up because you might need to move cables around. It is really hard to move cables down here where they're all cable managed and zip tied or Velcroed. I always recommend Velcro in place. With a patch panel, I can just unplug and move a connection, and now it's done up here where it's nice and easy. That's a great way to handle things there too. Notice how there's no real obstructions on the left or right side of these switches, so they have complete airflow that's able to move through, and there's even empty space at the bottom, knowing that if we add more machines, here there's we've got 3 48-port switches, so that's 120 some odd ports that we have available, and we can add more switches to that stack to increase it. Now, Once we figure out where we're going to put the switch, like in this case, it's a rack mounted switch, we'll screw that into the rack. It gets bolted into place. We provide it power. All right. So it's now on and we're ready to cable up our workstations. When we plug them in, you'll typically have more workstation ports, just what are considered access ports to plug them into. And that's what we're seeing here. Now, notice how some of these are orange and some of these are blue. People will often use colored cables to help identify what the device is. And I actually don't know in this particular picture, but maybe orange are VoIP phones and blue are computers. Or maybe it's that blue is one department and orange is another department. So it's a visual indicator that they're using. But there are some special cables you'll notice up here towards the top right, which are fiber optic. All right. In this case, these are typically going to be the trunks that connect these switches to the rest of the switching environment. And here I can see both of those cables are plugged into a blade right in this one switch, not into the other switches. So that means if this top switch were to fail, I would now lose connectivity to the main network from these other switches. That's not necessarily a good thing. If I go back to that other picture I showed you, this one, you can see where there's something similar here. I've got these two connectors up here on the one blade, but I've got another fiber connector here, another fiber connector here, and in fact, another two down here. So this is a little bit more of a redundant stack. It can handle additional nodes failing and allowing connectivity still going to the core, or this may even be the core, right? So those are all things that we need to be thinking about as we get this set up. Now, I mentioned we're going to power these on, right? So powering on the switch, if it's one big switch, it will likely have multiple power supplies, and those need to be plugged into ideally separate UPSs, which are then plugged into separate circuits. We're trying to plan for redundancy, right? If one circuit fails, the other circuit is still up, you're okay. If one UPS fails, the other is still up, you're okay. If one power supply fails, then so on. Many switches will have 4 or even 6 power supplies, especially if they do power over Ethernet. So you'll need the appropriate cabling for them. And be careful, some switches have plugs that look like standard computer D plugs, but actually have a little notch in them, which just designates they're a higher gauge. And that is important. You won't be able to plug a regular D plug into them. So make sure you have the right cabling to apply power to that. Once you've powered on the switch, if it is a standard layer 2 switch, you're done. The switch is ready to be used. Okay. But if it is a more advanced switch, like a Cisco switch, you're going to have a little bit of work to do, right? So for example, here I've got a Cisco switch that I did a factory reset on it and I powered it on. Okay. So when it powers on, you see a lot of different things going on if you connect to the console. And this is the same for an HP switch or Juniper or any other vendor out there. They all kind of work the same way. And when they power on, they go through various tests to verify the hardware is functional. And when they're done, you get dropped off at a prompt. And if you just want the switch to operate as a layer 2 switch, you're done, right? You start plugging things in and you're in business. But if you want to configure VLANs, divide up networks, assign a password, monitor statistics, all the things you can do with a managed switch, you will typically need to get in and configure it. And that might be via web interface, or it might be via a console connection like I'm doing right here on this Cisco switch. Now, if I press enter on my keyboard, it's going to see that this is a brand new switch, and it's going to offer to walk me through the initial configuration dialog. And wizards like these really help us to get the switches configured and up and running really fast. So I could say yes to that. It's going to ask me for some basic information. Do I want to do basic management? I'll say yes. And now I can give it a host name. Maybe this is my sales department switch or whatever it is that we want to call it. So you give it a name. I need to pick a password. So I'll punch in my password. I'll just say Cisco 123. And my enable password, I'll do Cisco 321. And my virtual terminal password, which probably won't actually get used, I'll do Cisco 123 again. Do I want to configure SNMP, the Simple Network Management Protocol? This will allow me to pull statistics into some kind of reporting software. I don't have that set up right now, so I'm going to say no. I can always turn it on later. And then after that, it's going to give me a list of the ports and their current status. I see several of my ports are up. Many of them are down. Nothing's plugged into them. But it gives me a chance to verify, am I seeing links where I expect them to be, right? And that's kind of our last step. Once the switch is configured and up and running, we need to verify that it's functioning. And you can do that from the front of the switch. If we go back to like the pictures that I had, you'll see all these link lights. And the link lights are telling me whether or not a cable has a connection and it's up. Now be careful when you plug a node in. Some switches are running spanning tree protocol by default. You may get no light, or you may get an orange warning light for up to 30 seconds while it does loop detection, and then it goes green. So just because you don't see a link light right away doesn't necessarily mean you're out of luck. You might just need to be patient. But if you start to see green lights, most of them will start to flicker, showing that traffic is transiting, and now you know you're in good shape. If not, it's time to move into network troubleshooting. All right, well, here we got a great chance to see what it takes to get a switch, well, purchased, configured, and installed and operational in our environment.